Alright, here's the second video with regard to fabricating or the fabrication of the low mount alternator bracket for the LT4. You're looking at the piece of billet aluminum. This is a 4" by 4" by a foot hunk of aluminum. I bought it from McMaster-Carr. It's about $100. So you figure the total cost of this bracket, it'll probably be about $140 because I bought a couple end mills to grind out the shape on the milling drill. And this is the bracket we need to fab up. It's fairly complicated, but we'll take it slow and one step at a time. The first thing we're going to do is just sort of carve out this channel. We're going to carve it out flat, back and forth, and then I'll tip one side up and grind one of the angles down, and then I'll tip the other side, and then we'll grind the other side down, and then we'll figure out where we go from here. But that's the first step. And you can see I used this blue dye, and then I used these micrometers, and I just sort of drag a line across that I could follow with the mill. So we're going to really just cut out this hunk inside the block, and then at some point I'll chop this end off. I'm really waiting for a new metal cutting blade for my circular saw so I can cut the end of that off, but I'm not going to wait, and we'll just get started and we'll get working. Okay, thanks for following along. Alright, we got this piece. Doesn't look too pretty, but it's locked down onto the plate of the milling drill, and we're just going to start to grind out this area here, and we'll pick it up from there. As you can see, this is going to take a while, so once we're done with this section, we'll segue back. Okay, here we go, the next step in the process. So we're really going to carve out the angle on this side of the bracket. I actually made a little bit of a diagram. The inside angle, it's 11 degrees on the shorter side, 5.5 degrees on the longer side. So basically just use one of these steel blocks. I used a digital angle or a digital level, 5.2. It's close enough, 5 degrees. And now we're going to shave out the inside of the block, and then I'll tilt it the opposite direction and shave out the other side, and that'll be the next step. Okay, so I'm done grinding out the right side recess area of the bracket, and actually this is the way the bracket's going to sit relative to the block. So essentially we ground out this area. If I slide it over, actually this is really where it's going to wind up being, roughly around there. Okay, so we ground this out. Now I have to adjust the block and grind this out, and then after we're done with that, we'll drill the holes, and then we'll flip it over on the side and then grind out this bottom part, and we'll be on our way to completion. Okay, slow but sure, we're getting there. Okay, well here's a little working process of you have it angled up about 10 degrees. We couldn't get it as high as 11, but essentially I'm sure to rotate this 5 cranks, 1, 2, 3, 4, 5. That brings it almost the width of the mill, and then I just crank this handle here. Literally do this for about 3 hours, and then the rest of it will be ground down, but that's not very exciting video, so I will segue once it's done. Okay, here we go. So the left side is ground out. You can see it's pretty clean. I got a little bit of extra material in here, but once I get the general shape and I can put it in a vise and tilt it a little easier, I'll clean all this up. The other thing is that I've undersized this. You can see the line here, the scribe line. I did that on purpose because I just wanted a get the general shape, do the heavy duty cutting. The next step is really to drill the 2 holes that are going to hold the alternator on. And then once I do that, I'll tilt it over and start to grind out the rest of the bracket. But so far so good, and I would think, you know, the top square area was probably 3 hours, this was probably 2 hours, this was about an hour. So about 6 hours worth of back and forth on the mill to grind this out. So it is slow going, but so far I'm very happy with the way this is turning out. Okay, so here's the next step. I basically disassembled the brackets, just screwed together. And the idea is I wanted to be able to start to shave this area down. But in order to do that, I need to place these side brackets on both sides of the block in the perfect spot. So what I figured I'd do is I would drill the holes for one bracket and then drill all the way through to the other side. And that way I can take the other bracket and then do the outline, and I can just start shaving the back, the bottom part of this block down on both sides, and then I'll be close to completion. So I've got 2 drill bits, a shorter bit to just drill the first section, and then I have a longer bit to drill all the way through. You know, the drill press only goes up so high, so I needed a short bit to get started, and then a longer bit that I could place it in the block and then pull it up into the chuck and then drill away. So anyway, this is the next step, so on to the next segue. Okay, this is a little bit of a delicate operation here. I drew a circle and an X in the middle, and then used a counter punch to mark the exact center of where I need these holes to be. Then I use one of these Christmas tree bits just to get it started, and it's a nice and round hole. It's rounder than a regular bit, and I think it's certainly where it needs to be at this point. So now I'm going to draw out an 8.5 millimeter hole because I want to tap this thicker piece, and then down below at some point I'll drill out the 10 millimeter hole for the bolts. So anyway, that's what we got to do. Gonna cross my fingers and hope this comes out good. Alright, 1 down, 1 to go. So this one came out perfect. Turned out I didn't need the longer drill bit. I was able to use maybe a 1/3 of an inch left on the tip of the drill to drill it through the bottom part. So I figured I'd turn it so the thicker part is on top, so it didn't need too much grip on the shaft to drill this bottom part, which is a 1/2 inch. So anyway, deep breath, 1 more to go. I think it's going to line up pretty good, and we'll take it from there. Okay, one other technique I use is, I draw a circle and then I use some clear plastic. And I use that clear plastic as a ruler, and then I mark an X, and then I use a counter punch. But then it's like, how do you center the mill, in the hole? So what I do is I take a thin bit. If the drill is not lined up properly, as you touch it, it's going to bend. Like right now, it's lined up perfectly. And now I'm going to move it just a little bit. And now you can see when it presses in, it just bends a little bit. So I'm going to straighten that out. I can't do it, holding the camera, but that's how I get the dead center on a circle for something like this. I mean, it's not 100% precise, but for drilling holes and brackets and things like that, where you still need a level of precision, it works out pretty well. Okay, so now with the Christmas tree bit, that looks dead on. So, sometimes I have to adjust it a little bit. In this case, I did. Now I'm ready to use the longer bit, and it'll be dead center. Okay, so far so good. So we have 2 holes drilled. They're 8.5 millimeter in diameter. On this side, I'm going to tap these out for 10 millimeter bolts. I wanted to basically, when I mount the alternator, mimic the factory alternator mount, which is a 10 millimeter bolt goes through a 10 millimeter hole into 10 millimeter threaded threads on the bracket. So I just figured it's easier that way, you know, because I don't know what kind of stuff I'm going to have mounted all inside the engine bay, and if I have to pull the alternator out, I figure it's just a little easier to unscrew the bolts and take them out versus having to get your hands back there and put some lock nuts on it. Which, you know, if this winds up not coming out right, that's what I'll do. But I just figured I'd give it a try and see if I could mimic the factory setup. So far so good. The next setup really, or the next step, excuse me, is, oh, this thing's heavy still, is to drill these holes out. So I've got to center the 8.5 millimeter drill in the milling drill, and then I'll drill a 10 millimeter hole, and then I can take the bracket with 10 millimeter bolts and line it up and then trace it out. And once I trace it out, then I can start shaving this down. So I'll have identically traced parts on both sides of the block, and that'll let me machine this thing down. Then I'll chop these sides off and I'll pretty much be done. You know, I'll leave a little excess on the fixture just so I can get the alignment with the belt correct. So I could always just shave it down a little bit at a time to get the belt perfect. That's the way I determined the width on the compressor bracket I fabbed up. So anyway, just a little extra theory here on the bracket. It's a lot of work. Okay, so we got the part back on the milling drill, and I've centered the 8.5 millimeter bit, and I'm going to swap this bit for the 10 millimeter bit. Hopefully I have enough room to thread it in there. Sometimes you don't when the bits are a little tall, but we'll figure that out. Okay. Alright, turned out I had to use a hand drill to drill this. I didn't have enough clearance on the mill for such a long bit, but anyway, this is a 10 millimeter bolt. Fits in there nice, not, you know, it's not loose, but it slides in nice. And then this section here, this will wind up being 3/4 inch, and then we'll thread these holes. So we'll have the bolts just drive all the way through the alternator and tie in. Also, right around here, I'm going to insert a steel bushing, 15 millimeter steel bushing at some point, and that bushing will slide in and press into the alternator. That's the way the factory works. But anyway, we've got the shape on the block, and I'm just going to spend you know, a bunch of hours grinding this thing down, and then I'll chop that side off, chop that side off, clean it all up, and I'll be done. Okay, so at this point we've got the block clamped back down on the mill, and you can see my techniques are really improving here. I mean, this certainly looks better than the way I was doing it before. I found this nice solid piece, short, nice and stable. So essentially we just got to angle this so that it mills this area straight. I can do this by trial and error because this line is actually sort of down here. Basically it's going to drop down about 3/4 inch. So I'll just play around until I get this perfectly parallel to this line. Then I'll bring it in closer, and then I'll bring it down 3/4 inch, and then I'll cut this area down 3/4 inch, and then you know, then I'll decide what the next cut will be. All right, here we go. That's the first pass, and you know, it looks pretty parallel. You know, maybe a hair wider on the left side than the right side, but I'll just adjust it and then I'll start grinding. It doesn't have to be perfect, and I'll grind this down 3/4 inch. Okay, here we go. So it's actually starting to look like an alternator bracket. Let's see. Originally I was going to cut this whole area down 3/4 inch, which really represents sort of this area on the bracket. But what I realized is if I just cut one channel at a time, I literally can cut deeper, because I guess you know, this is a pretty light duty machine, but because there's now a pretty deep channel, it sort of gives this blade stability, and the machine runs a lot better. So, you know, each one of these turns, you know, brings the head down or up. Each turn is a 1/16 inch. So now it looks like I can get just about a 1/2 inch turn, Before I was only getting 1/4 of an inch turn. So I literally can speed up my cutting by almost twofold, which is great. Okay, and let's see, it's, now look, there's the crevice back there, and it's starting to look like a bracket. Pretty cool. All right, so this is where we're at here. We've cut all this area out, so you can get a sense for what we're trying to do, which is really just sort of drill out this recess here, and then we'll cut this area out at another time. I still have a little too much material here, so the next thing I'm going to do is grind this area out or mill this area out, and then I've been thinking about how to approach it after that, and I'm simply going to turn this over in the mill. It's actually getting lighter, which is nice as I grind it away. And I have some extra long mills that I bought just for this project, and because I have this very accurately carved here, I'm literally going to mill a short line. Just mill it through the block here so I can get the chips out. I'm going to mill this all the way down this V, and it should, you know, peek through this area here, and that'll be sort of the shape. So I think I'm going to wind up just cutting all this out, then I'll chop the sides off, and then as the last thing I'll grind these tops out. So that's sort of my approach right now, but so far so good. As you can tell, it's a lot of work. Just got to go very carefully because it's easy to turn the wheel the wrong way and screw the part up. So hopefully that doesn't happen. All right, well, here's the next step. So I've decided to turn this over because I've got a nice crisp line for this bottom piece of the bracket. I have an extra long mill end that I'm going to use, and I'm literally going to cut all the way to about 3/4 of an inch down because the opposite side was ground up 3/4 of an inch down. And I should have a nice square, you know, square cut here, and so essentially I'll cut this all out, I'll cut this all out, and this out, and then we'll take it from there. Okay, well, after about 3 hours of milling, and you know, I use this long mill, and it really didn't work all that well. It kept trying to grab the aluminum and sort of work its way in like a drill, and was bogging down, and the inside edge isn't really that clean, but I can clean that up. I should have made this line a bit further away, and then I could machine it down perfectly when I'm done. It won't really affect the bracket, but in hindsight I should not have been so bold to think that I wouldn't have an issue. You know, these smaller mills, even though they're pretty thick, work great in this machine, and I got it down about that far, and then I had to go to this longer mill, and it just you know, my machine's just not heavy duty enough for this. But anyway, I ground this out, and then you can see, oh boy, just sort of flip this over. You can see it was a lot of work, but I got there's some glare here, but you can see I've got the bottom of the bracket done now, and then I'm going to do this side over here. I'm going to use a little different technique. I'm actually going to use some drills, so I'm going to basically drill a channel. I'm going to mill a channel for this piece here. Get away from the glare. I'm going to mill a channel for this here, but then I'm going to use a drill and drill straight through. Then I'll use the shorter mill and mill that down quickly, then I'll flip it over and I'll use the mill, and I'll just keep it far enough away from this line so once I got the bracket done I could put it in the vise and mill it down really nice. So, you know, live and learn. I didn't ruin the piece, but I sort of learned a lesson. I mean, this is just a light duty machine, and you know, I'm sort of taxing its ability to make this, but you know, you can see we're getting there. I mean, you know, a lot of work. All right.